But is there any questions so far? We should finish chapter 6 today, and then we'll have the group assignment. And then your exam is over the last 2 chapters. I think it was 3 and 6. Any questions? In 6.3, I wanted to do a story problem. So let me share my screen. Some of this repeats some of the material you've already learned, which is nice, what we're tested on. Six point three. The price of an item in thousands of dollars where X is units of the item. Is P equals, now this is a lowercase p. When you see a lowercase p, it's price, and profit is a capital P. So P equals 10 minus 0.002x. So this is our price. So the first thing we want to do is find the revenue function. Revenue, R of X, is price that it sells for times quantity. Our price in this case is 10 minus 0.002x. Our quantity is X, because X is how many units we have or sell. I'm going to distribute the X. So we have 10x minus 0.002x squared. That would be your revenue function. Find the average rate of change of revenue. From 1,000 to 1,002 units. Now, average rate of change, that's your slope. So you can use this, or you can use y1 minus y2 over x1 minus x2. Either one. If you want also, we want to find the change from 1,000 to 1,002 using the revenue. So you can put 1,000 in here and then 1,002 in here and find the values. Or you can go under y equals and type your equation, which I already did. 10x minus 0.002x squared. You don't have to worry about the window because we're not going to graph it. We're just going to go to table. So second and table, and then you type in your 1,002 and your 1,000. And there's your 2 points. X1, Y1, X2, Y2. So we subtract our y's and subtract our x's and get 12 over 2, which is $6,000. So when we go from selling 1,000 to selling 1,002, we increase our revenue by $6,000. Any questions on that? Any questions? Let's find the instantaneous rate of change at 1,000. So remember, when it's instantaneous, that's when you take the limit as b approaches your value, which is 1,000, f of b minus f of 1,000 over b minus 1,000. So we need to find f of b. We found f of 1,000 already. It was the 8,000. Table. When we plugged in 1,000, we got 8,000. And the limit as b approaches 1,000. F of b, plugging that in for your r squared, your r, would be 10b minus 0.002b squared. B squared. Minus the f of 1,000, which was 8,000, over b minus 1,000. Any questions on that part? Okay. If you plug your 1,000 in, because remember when we're taking the limit, first thing we do is plug it in. When we plug it in though, we get 0 over 0, which means that this b minus 1 is a common factor with the top. But before I try and factor it, I'm going to put this in order. The b squared should be first when you're trying to factor. So the negative 0.002b squared plus the 10b minus 8,000. Now you could factor this by trial and error. You can factor it by grouping. You can factor it by the x, that big X that we did the multiply and add on. But to get 0 over 0, this b minus 1 has to also be on the top. So we know the one factor is b minus 1,000 because that's what's getting us our 0 on top and on bottom. Now you only have to worry about this first term and the last one. The middle will fall into place. Otherwise, we wouldn't have had 0 over 0. So for the negative 8,000, we plugged 1,000 into this equation. Since I had already found it here when I plugged in 1,000, I didn't plug it in again. So under y equals, oops, shut off. Under y equals, I put the equation 10x minus 0.002x squared. And then I went to the table, second and table. And when you put the 1,000 in, you get 8,000. Now you could have just plugged it in 10 times 1,000 minus 0.002 times 1,000 squared, and you get 8,000. And then if you change that 1,000 to 1,002, you get the other one. Now that's making a decimal. The table must have rounded. Yeah. So it rounded it to an integer. Remember, if you do need decimal places on MyLabs, just highlight the number and it shows you it here. You're welcome. So that's how we got up to the 8,000 here. Now we know these two have to be a common factor because of the 0 over 0. To get the factor here, first we look at this b. B times what is going to get me this first term? Because these two have to multiply together to get that first term. Well, I have a b, I need a negative 0.002 to get the number, and I need another b to get b squared. So now when I multiply these two, I get my first term. To get my last term, I have to take the negative 1,000 times something to get a negative 8,000. So what times negative 1,000 will give me a negative 8,000? Positive 8. 8 times a negative 1,000 is a negative 8,000. You don't have to worry about this. It'll fall into place. But if you are worried, multiply the outside 2 and the inside 2 and you'll get 10b. Any questions on that? Okay. Then notice these two cancel. Limit as b approaches 1,000, negative 0.002b plus 8. Now we can plug our 1,000 in. So I have $6,000. Now that seems kind of strange because when we went from 1,000 to 1,002 units, our revenue increased by 6,000. So we're going from 1,000 to 1,002. When we sell two more, we make a revenue of $6,000. But this instantaneous rate of change is saying we're selling 1,000. If we sell one more unit, we'll make $6,000 in revenue. So if we're selling 1,000, if we sell one more unit, we increase our revenue by $6,000. The other one was saying when we're selling 1,000, if we sell two more, we're increasing revenue by 6,000. Kind of strange that that second one isn't giving us any revenue. But that can happen. Because if you think about it, if you have enough material to make the 1,001, when you sell that 1,002 one, if you need to buy more material, then you're not going to make as much. And so that could be the reason. Also, your revenue is a parabola. And because the negative, the equation here, the squared part is negative. Remember, the parabola goes down. So we could be hitting a point where it's going down, or the rounding was so small that it rounded to 6. But for some reason, the second one isn't bringing us in any revenue. Any questions on that? No questions? Six 6.4. 6.4 is the definition of the derivative. The first one is the difference quotient. And we've learned this already. That's your slope, f of b minus f of a over b minus a. The other is the derivative. Now for the symbol for the derivative, it's f prime of x. So this little prime, kind of like a, not a comma, but a little tick mark. So it's not a 1, it's a tick mark, but it means the first derivative. If there's 2 of them, then second derivative. 3, third derivative. After that, they start putting numbers. 4, 5, 6. But this just means to take the derivative. The derivative that we learned already, and actually we're just using, is this one. So this is one way of taking the derivative. Another way is the limit, or not limit. We'll just put 4-step process. which we'll outline below. Now, the main thing is knowing the proper wording so you know which one to use. When you're using the difference quotient, it would be the secant of a line. For a secant, when you have a line, this is our graph, you're going between 2 points and you're finding the slope between them. For the derivative, it's the tangent of a line. It should say slope of the tangent. Both of these should be slope. The tangent line is where it touches at one point. We're just given one value. And that's why it uses the derivative. Remember, we use this when we have one value, we use this when we have two. So the slope of the secant line is this formula, the slope of the tangent is the derivative. Also, for the slope is average rate of change and we mostly would use it for profit, revenue, and cost. So if it says average rate of change, then you're using this. It says instantaneous rate of change. For profit, revenue, or cost. Then it uses either the 4-step process or this limit, either one. And one more. A lot of times instead of instantaneous, they'll say marginal. So marginal cost, revenue, or profit. So the key word is marginal and instantaneous use the derivative. Average rate of change uses the difference quotient. Also remember you're given 2 points for these. You're only given 1 for these. Any questions on that? I'm not sure if they have some of these on my math lab. When you're finding the slope of the tangent line, it touches, the blue is the graph, the red is the tangent line, but it touches the graph at one point. So then to find the slope when you have a graph, you just count. Start at the leftmost point. We have to go up 2 and over 1. It's your rise over run. So up 2, right 1, slope would be a positive 2. Your graph's going up, the slope is positive. When it's going down, it's negative. So if we look at this one, it's going down 1 and right 1. So that's -1 over 1. Slope is a -1. So from the leftmost point, down 1 over 1. This part's kind of a review, except you're calling it a tangent line. This one, we'd go from the leftmost point up 1 and over 1, 2, 3, 4. So it's 1/4. Now these two, notice this is a horizontal line. So the slope is 0. It's also a low point on the graph. So when you have those tangent lines are horizontal, you're finding the highs and the lows of your graph. So we'll use this a lot in other chapters. And then this one is the vertical line. Of course, when you have a vertical line, your slope is undefined. Any questions on that? I think you know how, I hope you know how to count the slope. But the main thing, I like this one because it's showing you when the slope of the tangent line is 0, you're at a min or a max. Let's try a couple derivatives. Oh, let me give you the 4-step. Now, if you want to do the steps all at once, that's fine, because sometimes you can't even simplify. But the first step is to find f of x plus h. And then if you can simplify, you simplify. The second one is to find f of x plus h, which you just did, and subtract the original function. And things should cancel. The third step, divide by h. Should be looking familiar. The limit as h approaches 0 of f of x plus h minus f of x all over h. So these are the 4 steps, but if you want to do them all at once, I'm fine with that. When you have a polynomial, be careful. A lot of careless mistakes happen all at once. But then when we do the square root one, we're going to do it all at once because there's nothing to simplify before that. So those are our 4 steps. Let's see, f of x equals a negative 4x squared plus 9x plus 2. And we want to find the derivative. And then we're going to plug some values in. So anytime you're given one where they ask you find f prime of x, f prime of 2, f prime of 0, and maybe f prime of negative 2, find this one first, and then you just plug these values into it. So using the 4 steps, the first thing we find is x plus h. That means wherever there's an x, we put x plus h. Any questions so far? Now this x plus h squared means you take x plus h times x plus h and FOIL it. We have negative 4 times x squared plus 2xh plus h squared. That was just foiling this. I'm also going to distribute the 9x plus 9h plus 2. Distributing the negative 4, I have a negative 4x squared minus 8xh minus 4h squared plus 9x plus 9h plus 2. So I distributed this 4. And there's no like terms, so nothing will combine. Any questions on that part? So that's step one. Step two is to subtract the original function. So we're going to subtract negative 4x squared plus 9x plus 2. Now, if you don't want to rewrite it, you can distribute this negative inside the parentheses and it changes all your signs. Also, when you start combining, these should cancel with something out here. If they don't cancel, you did something wrong. Also, all the terms that are left should have an H in them once these cancel. So first thing, I'm going to distribute my negative. So that's going to make this a positive, and then negative times negative is a positive. The negative times this 9 makes this a negative 9 and a negative 2. So it changes your signs. Then we notice we have a positive 4x and a negative 4x squared. So the 4x squareds cancel. We have a negative 9x and a positive 9x. So this should be an H. Be careful. One of them's an X and one of them's an H. And the X's are the ones that cancel. Negative 9x and a positive 9x. A negative 2 and a positive 2. Any questions on that? Notice there's 3 terms left. 1, 2, 3, and they all have an H in them. So f of x plus h minus f of x all over h is a negative 8xh minus 4h squared plus 9h. So we're going to divide by h, but I should write that first. So we have our function. We canceled a lot of things. Everything left has an h in it. So I want to divide by h. This is step 3. Now you can factor an h out of the top. If we pull an h out, that leaves a negative 8x. Pulling one h from here leaves a negative 4h, and then pulling this h leaves 9 all over h. And then the h's cancel. Notice the terms, these are the terms that are left once we cancel these 2 h's. Any questions on that? Now, if you wanted to, instead of factoring, there's 1, 2, 3, 4 terms. All of 4 terms have an h in them. So I can divide them all by h. When I divide it by h, these 2 h's cancel and leave a negative 8x. This cancels with one of these and leaving negative 4h. And then these 2 cancel and leave a positive 9 over 1, which is exactly what we have here. So it's up to you which way you're comfortable reducing it. Doesn't matter to me. Any questions so far? That was step 3. Step 4 is to take the limit. Which means the limit as h goes to 0, we plug 0 in for h. So the negative 4 times 0 drops out. And this is our f prime of x. Any questions on that? So we wanted to find 2 at 0 and at negative 2. Well, once you find this one, then you just have to plug into here. You don't have to go through all the steps again. Negative 8 times 2 plus 9, negative 16, 7, negative 7. Plugging in 0, negative 8 times 0 plus 9 is just 9. Negative 8 times a negative 2 is 16, plus 9 is 15. Any questions on that's not right. This is positive. I just forgot the 2. $25. Any questions on that? Okay, let's try a square root. When you have a square root, notice if we find f of x plus h, there's nothing to simplify. So we might as well find f of x plus h minus f of x all over h at once, because we can't do anything until we put that h in the bottom. Because when we subtract the negative 3 square root of x, we still can't combine. We can make this a positive, but we can't combine these. They're not like terms. So the first 3 steps need to be done before we can simplify anything, other than negative times negative is a positive. Any questions on that part? We have negative 3 square root of x plus h plus 3 square root of x all over h. When you have radicals and you need to simplify them in a fraction, you multiply by the conjugate. The conjugate is the exact same thing, but the opposite middle sign. So instead of the plus, you make it a minus. So the only thing that changes is the middle sign. And you do that on top and bottom. On the bottom, don't multiply it out. I'm going to put a plus there. Don't multiply the bottom out because we want this h to cancel before we can take the limit. Now on this part, when you're foiling it, because it's the conjugate, you only have to multiply the first two and the last two. You don't have to worry about outside and inside. They cancel. So we multiply these first two. -3 times -3 is a +9. And then the square root of x plus h and the square root of x plus h is x plus h. The square roots cancel when it's the exact same thing. Then we multiply the last two terms. 3 times -3 is a -9. Square root of x times the square root of x is x. Over h times -3 square root x plus h minus 3 square root of x. But I'm not going to factor or factor that in. Leave it out. But I will distribute my 9. 9x plus 9h minus 9x. The 9x's cancel. We still don't want to take the limit until this original h cancels. And notice now we can cancel it. We couldn't before because there's 3 terms on top. So you can only have 1 term on top and bottom. This is 1 term. So now this h can cancel with that one. And we can now take the limit as h approaches 0. So once this h cancels, you can take your limit. Just plug 0 in for h. Remember, you only plug the 0 in for the h. H is going to 0. So f prime of x equals 9 over, this becomes the square root of x, so these can be combined to a -6 square root of x, which reduces by 3. Now, I would be fine if you left it like this on a test. Technically, you're not supposed to leave a radical in the denominator. But if you can go through all of this work and have the correct answer, I'm fine with this. I'm not sure what my math lab does. I think, well, last year they let you leave it, but they might have changed it. To rationalize it, if you remember, you multiply by the same thing, the square root of x over the square root of x. So then on top we have 3 square root of x. On the bottom we have a -2x. Because it's not proper to leave a radical in the denominator, but I would take either one of these answers. Any questions on that? Okay. No questions? Awesome.